In the star social event Orion, there is a star that has charmed cosmologists for a genuinely extensive time frame: Betelgeuse. This red, especially huge star is significantly more noteworthy and more enormous than our Sun. In later years, Betelgeuse has been acting especially strangely. It has diminished significantly and has even begun to vibrate viciously. This has prompted speculation that this once extravagant star is moving toward a self-important impact. Yet, think about how conceivable it is that we are really seeing the beginning of a more tricky and upsetting event. Consider the likelihood that frightening little creature Betelgeuse won't detonate, but all things being equal, collapse on itself. Join us as we investigate the latest research on Betelgeuse and its likely ramifications for our planet. Through this examination, we intend to understand the basic impact Betelgeuse's collapse could have on the future of the universe. Betelgeuse is a monstrous star, on different occasions more noteworthy than our Sun, and is among the universe's largest. However, its size comes with a cost. Stars like this have limited lifespans, and Betelgeuse is no exception. It's a ticking time bomb prepared to detonate. Yet the specific moment remains a mystery. Arranged around 650 light-years away, Betelgeuse has amazed cosmologists, shining as one of our closest stars. We marvel at its brightness, attempting to disentangle the secrets hidden within its fiery depths. However, only 13.3% of its splendid energy is visible to us. If we could see its full splendor, it would outshine even Sirius in the night sky. Imagine a titanic star with a radius commonly that of our Sun, extending beyond the asteroid belt and almost touching Jupiter. Within this enormous region, Earth, Mars, Mercury, and Venus would be immersed by Betelgeuse's monstrous gravitational force. But the surprises don't end there. Every few hundred years, Betelgeuse sheds a solar mass, pushing off its outer layers in a brilliant display of cosmic beauty. A cloud, commonly larger than the star itself, envelopes Betelgeuse, covering it in an ethereal mist that captures our gaze. This cloud, extending 30 light-years, invites us into a grandiose celestial dance, coaxing us to reveal its secrets. We ought to plunge deeper into the heart of Betelgeuse's creation, where the nuclear fusion of hydrogen creates helium in a massive release of energy over time. As the star's hydrogen fuel decreases, a great transformation occurs as helium fuses with carbon, producing brilliance that travels through the universe. Yet even this great fusion has its limits. As neon combines with iron, a stunning change happens. The star's gravity, weakened by the loss of energy, triggers an impending collapse, pushing Betelgeuse toward a fate that is both awe-inspiring and terrifying. A cataclysmic explosion. Stars go through an entrancing transformation, progressing from the dynamic blues of youth to the bursting reds of old age. During the 2nd century BC, Chinese astronomers saw an unusual visible phenomenon. Betelgeuse's distinctive yellow shade set it apart from the divine tapestry. As the centuries unfolded, the bar of observation passed to Greek and Roman astronomers, such as Hipparchus in the 2nd century AD. In his detailed records, he described Betelgeuse as having an orangish or tanned appearance, a characteristic that still charms us today. This relentless tone, noted across various cultures, contributes to the fascination surrounding Betelgeuse. The story of Betelgeuse takes a new twist as we dive further into its capricious behavior. In 2019, the star astonished experts by suddenly dimming. Specialists initially believed that a massive dust storm, released from the star's surface, had obscured our view. However, the origin of the cloud remains unclear. Some researchers speculate that a massive object, like a planet, might have upset the star's surface or even been consumed by it. Recently, Betelgeuse has become twice as bright as its typical brilliance. This is astonishing, since stars usually dim as they age. Experts are uncertain about the cause of this sudden increase in brightness, but they do know that celestial luminosity can vary due to many factors. Some stars go through cycles of brightness and dimming. Betelgeuse is classified as a variable star, as it changes in brilliance, expanding and contracting regularly, altering the amount of light it radiates. This is a common event with many stars, including Aldebaran and around 30 other stars visible in the night sky without a telescope. Inside Betelgeuse's core, a seismic shift is occurring, with the release of bursting material into space, creating a massive dust cloud of gigantic proportions. This dust cloud obscured a significant portion of Betelgeuse's brilliant light, transforming it from a striking beacon to a dimmer star in the night sky. Betelgeuse's brightness dropped to levels previously unimaginable. Once considered among the top 10 brightest stars, it now ranks lower than the 20th brightest. In recent months, Betelgeuse's behavior has stunned cosmologists, challenging the norms of stellar behavior. Some suspect that massive sunspots or dust fogs are responsible for its dramatic changes, while others have investigated the possibility of repeating patterns. Their research has revealed the unsettling thought that Betelgeuse's cosmic explosion may have already occurred. Yes, you heard that right. While past estimates projected its grandiose blast event to be centuries away, current evidence suggests a different story. The massive explosion could be the next major celestial event in our galaxy. Some experts propose a model suggesting that Betelgeuse is in the late phases of carbon burning, indicating it could be approaching a significant explosion. This positions Betelgeuse as a strong contender for the next expected cosmic explosion in our Milky Way. Predicting the exact timing of a supernova is a complex and challenging task. While scientists can estimate the probability of a supernova based on a star's age and behavior, exact predictions are difficult due to the many factors involved. Factors such as the star's mass, composition, and overall environment can influence the timing and nature of the explosion. Current models of stellar evolution and supernova mechanics provide valuable insights, but much still needs to be understood about the specific conditions that lead to a cosmic explosion. Continued observations of Betelgeuse and other massive stars are crucial for refining these models and advancing our understanding of these magnificent cosmic events. The study of Betelgeuse offers critical insights into stellar evolution. By examining the star's behavior and characteristics, researchers can gain a deeper understanding of the life cycles of other massive stars and the processes leading up to supernovae. Betelgeuse's extraordinary properties, like its size, brilliance, and erratic behavior, provide valuable information for developing and testing theoretical models of stellar evolution. Furthermore, studying Betelgeuse's interactions with its environment and its eventual supernova will contribute to the ongoing patterns of cosmic evolution, affecting the development of new stars and planetary systems. The dramatic nature of Betelgeuse's behavior has captured the public's imagination and sparked widespread interest in astronomy. Educational outreach programs and popular science articles often highlight Betelgeuse as an example of the intriguing and dynamic processes occurring in the universe. Public engagement with such topics fosters curiosity in science and promotes a broader understanding of celestial phenomena. As technology continues to advance, future observations of Betelgeuse will provide even more detailed insights into its behavior and evolution. New telescopes and observational techniques will allow scientists to monitor the star's movement with greater precision, uncovering additional clues about its impending supernova. Researchers are also exploring the use of computational models and simulations to better understand the processes occurring within Betelgeuse and other massive stars. These models help predict the star's future behavior and refine our understanding of the mechanisms driving supernovae. The study of Betelgeuse offers a stunning look into the life cycle of massive stars and their impact on the universe. From its immense size and complex fusion processes to its potential as a supernova candidate, Betelgeuse remains a central focus in the field of cosmology. As we continue to explore and understand this remarkable star, we gain valuable insights into the dynamic processes shaping the universe. Its eventual explosion will not only mark a monumental event in the cosmos, but also contribute to the ongoing cycle of star formation and chemical evolution in our universe. Betelgeuse's upcoming explosion as a supernova holds a fascination for astronomers and the general public alike, as it promises to be one of the most spectacular cosmic events that could be witnessed from Earth in centuries. Yet, beyond the sheer brilliance of such an explosion, its occurrence also offers a deeper understanding of the processes that govern stellar life cycles. This massive star, like others of its type, is an important laboratory for cosmologists trying to unravel the secrets of how stars live and die. Stellar evolution is a complex process driven by the intricate balance between a star's mass and the forces at work within its core. For stars like Betelgeuse, which are classified as red supergiants, the cycle of nuclear fusion is accelerated and reaches its final stages much faster than in smaller stars like the Sun. While our Sun is expected to live for approximately 10 billion years, stars like Betelgeuse can go from formation to their final explosion in a matter of tens of millions of years. This dramatic difference in lifespan is primarily due to the fact that larger stars burn through their nuclear fuel at a much faster rate, a process that ends in the formation of elements much heavier than hydrogen and helium. As Betelgeuse nears the end of its life, the core of the star is primarily composed of helium, carbon, and oxygen. In the core, the fusion reactions that sustained the star for millions of years begin to wane as the star exhausts its hydrogen fuel. The core contracts under the force of gravity, causing temperatures and pressures to rise dramatically. As this happens, the outer layers of the star expand, increasing its size enormously. These outer layers, made up of hydrogen and helium, are the parts of the star we see as Betelgeuse in its current form. It is these expanding layers that result in the star's red color and immense luminosity, which can be seen from Earth as one of the brightest stars in the night sky. Despite its immense size, the outer layers of Betelgeuse are relatively thin compared to the core, and they are held in place by the delicate equilibrium between the gravitational pull of the core and the outward pressure from the fusion reactions. This balance is what keeps the star from collapsing inward completely. However, as Betelgeuse runs out of fuel, the balance shifts. The fusion processes slow down, and the core's gravity becomes stronger than the outward pressure, initiating a catastrophic collapse. During the final stages of a red supergiant's life, the star undergoes a process known as a core collapse supernova. When the core reaches the point where it can no longer support itself under the force of gravity, it collapses inward at incredible speed, compressing the material into a much smaller volume. The outer layers of the star are then expelled outward in a tremendous explosion that releases energy equivalent to the energy output of the star over its entire life, often brighter than the entire galaxy that contains the exploding star. This type of supernova is one of the most powerful events in the universe, and it has the ability to outshine an entire galaxy for a short period of time. The explosion also plays a vital role in the cosmic cycle, enriching the surrounding interstellar medium with heavy elements such as iron, nickel, and silicon. These elements are forged in the star's core and scattered into space during the explosion. The debris from the supernova serves as the building blocks for the formation of new stars, planets, and even life as we know it. Beyond the spectacular display of light and energy, supernovae like the one expected from Betelgeuse offer invaluable information to astronomers. By studying the properties of the explosion, scientists can learn about the underlying processes of stellar evolution, the physical properties of matter under extreme conditions, and the chemical composition of the universe. These supernovae serve as natural laboratories that provide insight into the mysteries of the cosmos, allowing astronomers to test and refine their theories about how stars form, evolve, and die. Interestingly, Betelgeuse's eventual explosion could also have important implications for the nearby environment in the Milky Way galaxy. While the supernova itself will not be dangerous to life on Earth, it will significantly affect the local cosmic environment. The shock waves and radiation emitted by the explosion could trigger the formation of new stars in nearby molecular clouds, creating new systems of planets and stars. The elements released by the supernova could also contribute to the creation